All right, Cyber Patriots, let's check out one more video with IP network related content. Chapter 8 of, I think we're in the 4th module on subnetting IP networks. And again, I don't know how in-depth this is going to be from a Cyber Patriot competition standpoint. Probably very pertinent from a Cisco certification exam point of view. So we're going to go through some of this stuff. I'll talk about what's, from a practical standpoint, what's useful. Touch on some opportunities where you could check into some of the mathematics of it. Again, some things we might defer to later. Hopefully not competition pertinent. And if they do get us into some in-depth subnetting exercises in the content for the exam, we might end up conceding some of those in round 1 at least. So let's check this out, go through it a little bit, begin to get familiar, and then later when we get a chance to go into more depth, it'll come a little bit easier. So we're going to talk about subnetting IP networks. Okay, class activity called Call Me. And so that's a little kickoff thing they always do, going through there. Broadcast domains, basically sending lots of traffic to everyone on the entire network. Not a super efficient way to go about things. So if you could break the network up a little bit so that you don't have to broadcast things to everybody, just things to recipients that need it, a little more efficient for your traffic, better service. So we're going to delve in. Problems with large broadcast domains, slow operations, slow device operations, because it's got to broadcast all that stuff. So what we need to do is get it so that instead of everybody in one big crowded room trying to talk at once, let's break this up into some smaller meeting rooms where we can have more specific conversations and talk a little more efficiently amongst each other. Reasons for subnetting: one is location, secondly is organizational, device types, other divisions that make sense for the network. Also, there's security. You might want to separate things out so that you can firewall certain things off from each other. We'll get to that in a later slide. Octet boundaries. Okay, so here we are back to math again. We've got these subnet masks that tell us which part is the network and which part is the host for the network, specific network devices. And you can see here's one. Remember, a /8 means these first 8 characters of the network, or 255 here, because this 8 ones in a row in binary equals 255 in decimal, and then all the rest of this is a lot. That's a lot of possible numbers for client devices. In fact, number of hosts is over 16 million. That is one big network. Then there's a /16, which is all these are ones, all these are ones. So the demarcation is here between the 2nd and 3rd octets. Zeros here, zeros here. Even that gives you 65,000. Again, you're still talking scale-wise. That's a lot of devices in the network. And then the one I'm most familiar with, probably what you're looking at in your Wi-Fi router, if you did go IP config, you'd probably be like I am. Let's take a look and see if that's what I've got. And if my Wi-Fi 255.255.250, so that's what I'm using as well. And that's, of course, 3 255s in the first 3 octets, which translates to all ones in decimal. And then that gives us 254 devices. That's still a network of some size. Sometimes you'll get more than one set of numbers like these and combine them, as opposed to wasting a whole bunch of space on something with 65,000 you can never exhaust. Now you can subnet on the octet boundary, and sometimes you don't. So what they're saying is you're breaking it. I'll go back. You're breaking it actually on these octet boundaries. You don't have to do that. You can break it within an octet. And that's going to be their major topic here. So now you get into classless subnetting, and that's not talking about being mean and having bad manners when you subnet. It's talking about not using the classes like this, like the A, B, and C class addresses. It means breaking out the subnets themselves. So notice you've got what would have been instead of a 0, it's a 128 because of this one right here. That makes that 128 in decimal, as opposed to 1 and 7 zeros in binary. That would take this and break it into 2. Take this class C or /24 or 255, 250 network. Well, putting that 1 right there, that actually breaks it into 2 subnets. Instead of the number of hosts that we had here of 254, of course, that divides it in half, so you get half of 254, which is 126. You're thinking, and there's actually a -2 in there as to why that might not be 256 and 128 if you were paying attention on some of the math. And they'll talk about the why there's 2 fewer than you would think otherwise. Why isn't it 64 and 32 and 16 and 8 and 4 here? And we'll touch on that in a bit. So you can take these and actually take one, what was a 255, and add a 1 here or a pair of 1s here, and keep encroaching further on the network side, which are on the host side. And it gives you fewer and fewer possible numbers of computers, but it could break it up into more networks. And we're going to start touching a little bit into why you would do that. Okay, video demonstration of the subnet mask. That's a good one. I would look at that. Good background there. Subnetting with the magic number. Watch that, because that simplifies a lot of the math on how to do these things, on how to take one subnet and break it up into or one class of subnet, and then and break it up into fewer and make the math simpler. So again, that's probably a good one to get from a background standpoint and simplifying. So here's another example of classless subnetting, and they're just going to take what would be a 255, 255, 255, 0, and that's actually one series of 8 bits. They're showing the separation here because I think they're going to turn this part into network and leave only this part as host, I think is what they're going to do. All right, so now what they're doing is they're taking what was the 255, and they've broken this into 2 different networks. They've added a 1 and made this a /25. And so now you've got what would have been one network of what we would call a /24, a 255, 255, 250 subnet into a 255, 255, 255, 128 subnet. And it's a /25. And of course, 2 different network numbers, one a 0 versus the 128 network. And of course, there would be 2 different routing numbers, one for here and one for here, probably a .1 and a .129 for each of these. Because if and so also, let's talk about why you would do this. Why would you separate these networks at all? If you've got just 200 and something devices, that's not that much broadcast traffic. Why would you do that? Well, one thing you might do is maybe I want to take my servers and move them off to one side, and then my users' PCs somewhere else. I could take where this router is, and if they're separated, I could put a firewall interface in between here or in between here, and I could separate off my servers with just some firewall rules that protect them a little bit differently. So only the devices that need to talk to servers or a specific server can. Or maybe I want to do specific things with the firewall on the PCs so that they can or can't do certain things. You could even get, as I've seen things done, where you separate off a separate router segment for one system. Let's say maybe just your accounting or your financial system, your payroll, or one of the systems. I've actually seen this done at the state with the payroll system, EMARS, and it's got its own network with its own firewall. And that way you can say only people that have from these PCs are allowed to get into that environment. And that way you secure it. So that someone somewhere else gets hacked, well, they can't get to that network at all. And so it mitigates some of the security challenge that you could have with, instead of having everybody on one open or one flat network. So there is a lot of reason for doing some of this. And so being able to do some of the math, or like I said on a prior video, finding a subnet calculator to help you with it. But from a certification standpoint, Cisco standpoint, very important. From a Cyber Patriot competition standpoint, not sure. All right, so here's creating 2 equal size subnets. That's just a 2-minute demonstration. Check that out. And then subnetting formulas. These always honestly confuse me. I wound up doing just as well when I was taking tests and all that to just kind of do the math by myself instead of trying to do all the shortcuts. So those usually trip me up more than anything. And then again, they're just showing how you separate this out into 2 different ones. They're doing on 128, so that's just splitting a 255 network, Class C type network, into 2 of them, a 0 and a 128. Kind of, but they're also doing their little math trick as a demonstration. Now they're going to create 4 networks, so you can check out that example. And then 8, and probably, since these are short, probably good to go through some of those. That'll start to demonstrate the idea of, as you get 1s added over, or the 0s changed to a 128, and then it changes to 192, and then a 240, and so on. And seeing that increment from splitting into 2 networks, and then 4 networks, and 8 networks. And as the number of networks goes up, the number of available hosts per network goes down. Probably helpful. So creating networks with the /16, so you can see a series of slashes, what the corresponding subnet mask would be, how many subnets or how many networks that creates, and how many hosts are available. Again, you can see this scale. Good to understand this, but again, a lot of folks end up doing this enough to pass a test, and then from a practical standpoint, you probably end up memorizing this stuff if you're a network engineer that deals with it all the time, or if you deal with it occasionally but do deal with it some, you end up somewhere like this on the internet. Okay, and then they're really going out there with creating 100 subnets with a /16 network. So you're getting into pretty large count doing it like that. I can't say I've ever run into one quite like that. Okay, calculating the hosts, again some math to know how many. If you increase the number of networks, obviously each one can have fewer devices. So you wouldn't want to create a thing where let's put all our PCs on one subnet because we want to contain them. But you do it where there's only 16 possible hosts, and then you need to add the 17th machine. It's a problem. You got to redo your whole network because you didn't anticipate what your needs were going to be, or create a separate network and now your PCs are in different ones. So there's planning, and they'll touch on that. But there's planning that's involved in this too, and something we've talked about before, which is scalability. All right, creating a whole bunch of subnets. Feel free to check that out. Creating 1,000 network with a /8. A /8, that is really large. And then across multiple octets, useful, probably not necessary there. Subnetting based on host requirements. So this is where you start out with, I need to have at least this number of machines available, which is along here. At least this number of computers need to be on the subnet. That would dictate how you build it. You wouldn't take a network and I need to have 50 devices on a network together and then do the /27, 8, 9, or 30. If you can only get 30 machines on it, that's not even good for a 50. And if you had 50 devices you needed, one that can only take 62, any chance you could grow from 50 computers and printers and other devices IP addresses, could you grow from 50 up to the 63rd machine? If so, you actually need to think about the 126. So again, planning and predicting what your scale is going to be, very, very key. Now based on network requirements. So here it's how many devices do you need available? Here we're getting back to what we talked about with the network requirements. Maybe the sales group and the engineers and tech support. Well, the sales folks don't need to get into the very, very, the research and development that might be very sensitive. Maybe there's trade secrets involved. The sales guys don't necessarily need access to that. So you might want to separate those networks out so that you can have only the engineers get to their stuff and the sales guys get to their stuff, and R&D gets to its stuff. HR, of course, could be key. So in order to protect that particular data, you could separate the things into different networks, put different firewall interfaces in front of each one, and then do the rules on your firewalls so that only the appropriate people can get to those resources. And again, just more repetition on network and host. Now here's one with having you exercise. I'd recommend doing this one. Look up, if you need backup, just look up, something that's in binary like that, or a cheat sheet, or IP subnetting database. But this one actually is pretty good here, this net mask conversion. That's a good one. So, but you just go in and you're supposed to figure out like how many ones and zeros. And so the net mask on this one, if it's 255, that has to be 8 ones. That has to be 8 ones. Whoops. Also 8 ones. And then 248 I got to think about. So that would definitely be a 128, 192, 224, 240, 248, and then 30. And that's a /25, 6, 29. Is that right? Hey, okay. And then you can do a new number and go through those and practice that. And again, same exercise, a little more to it. So now you start with, I need 25 hosts. So that means how many, this one you might not, that's probably a little more in depth. But if you need 25 hosts, that means you need to do something that's like a slash that's going to have at least 32 numbers in it on the host side. You could look at something like a net mask converter. No, this one doesn't have the number of hosts for you, so that won't help you. So that one, good exercise if you're going to tackle it. Not essential for Cyber Patriot, I'm sure. Okay, calculation exercise, that's fine. Packet tracer, we'll get into the packet tracer exercises at a later time. Addressing scheme, designing the scheme, which again, we've just been talking about the requirements. And then traditional subnetting, wasting addresses, which is true. So then they get into variable length. So then instead of cutting your network in 2 halves of 128 each, what if you cut it into a half and 2/4? Because that's really how your network design was sets up the best. Maybe you have only a couple of people in the R&D, but a whole bunch of people in sales. Well, if they're all equal size subnets that you chop your network up into, it might be wasteful to have, let's say, 64 spaces for the sales, and it makes sense. But having 64 for the engineering, the R&D team, let's say, and there's only 8 of them, well, that wastes a lot. So you can chunk it up a little more into uneven fractions. And we call that variable length subnet masks. And that's, again, something that's probably beyond the scope of what we'll run into from a competition standpoint. Definitely accountable, though, in a testing environment. So there's even some charts. So, and that's what a lot of this stuff is done, is you want to understand the concepts. It's kind of like learn how to do the math by hand, but then once you've got it, pull out the calculator and save the time, or look it up on your favorite IP subnet calculator site. All right, so now we're going to get into, oh, okay, this is a good exercise because even though we don't necessarily have to go in detail on the large scale, honestly, should be able to figure this one out. It's a lot of logic, not really any math to it. So I would advise doing this exercise. It's a good one. Address planning, that's the same thing. You know, the students don't need to be on the faculty end. The administrators probably would say they don't want the faculty in there. So that's separating the things out. How many administrators are there versus how many students? Probably not proportional at all. And so you might want to do some of that variable scale when you do your subnetting. So they're just kind of talking through some examples as to why you would do some of the stuff they're talking about. Okay, prevent duplicates. Okay, so this is just some of the planning stuff. That's worth a quick read. Assigning devices, that's all fine. Packet tracer, defer to later. The lab on the VLSM scheme, we'll defer. And now we get to IPv6, and guess what we do here? Next. Okay, and that was subnetting at v6. No thanks. And class activity, can you call me now? So again, like always, there's the callback to the original conversation. Feel free to check that out or not. Okay, back to the skills integration. That's always the last lab or last activity, and they try to have you do something that pulls it all together. This will be a lot of fun when we get into this. A little early for us to get the packet tracer stuff. We got to get everybody where they got their hands on the tool, but it'll be great because you can basically build your own network, computers and routers and subnetting and all that kind of stuff, and pretty much simulate everything you would run into as a network engineer. And it's a lot of fun to mess with too. And we'll probably get a video on that and then start doing some of that in practice after we've gotten through competition run 1. And there is chapter 8, and that will do us for this video. So thanks for watching, and we will see you again soon.